Hello, humanoids, and welcome to episode 10 in our course on ethics and science. This is a very brief and very selective history of science. As always, it's Adam and Admiral Akbar coming at you for another look at the many dimensions of ethics and science. And so this is not a course in the history of science, thank goodness, because that's a whole course in itself. But historical awareness and context, I think, is really important for thinking through the ethics of science. And so I'm just going to give here some highlights on this sort of selective tour through the history of science. First, though, a new segment, new feature. This is Akbar. Akbar wonders about science and stories and questions Adam's Eurocentrism. he's giving me a lot of trouble here. This is in your notes. Check this out. It's a story about bees and elephants. Elephants in Kenya and in many other parts of the world were causing havoc with farmers, trampling their crops, and often even injuring or killing people. And this is a story of scientists who went over there and were trying to solve this problem in a way that was good for humans and elephants. And it turns out the scientists were reading stories of Kenyan folklore about bees scaring elephants. And they built these very cheap, easy to do bee fences. So it's what you're kind of looking at here. And long story short, when the elephants trip a wire or when people see elephants coming too close, they shake these bee boxes a little bit and the bees come out and it scares the elephants away. And it's good for everybody. They even produce bee honey, honey that's elephant safe honey. And this got Akbar thinking, that whole story Adam tells about how science is a non-narrative form of rationality. Well, the stories they looked into in Kenyan history were basically telling them about science. And this wasn't a European form of science, but nonetheless it was science. It was observation about the way the natural world behaves that allowed them to predict certain things about bees and elephants interacting. And so this is what we might call an indigenous form of knowledge or something like that. So this is all just to say I'm going to give you a quick tour that's primarily a selective tour of European history of science. But let's not let us think that means that's the only way to tell this story of the history of science, or that science isn't in itself a perennial human experience and accomplishment. Okay, enough on that. Oh gosh, and then I had you read one other thing. You are in this module watching a couple episodes of Cosmos, and I just love this show. Akbar just can't get enough of it. It's his favorite. Of course, it's got a spaceship in it. A couple of points from this show that I just wanted to highlight. I think it's really interesting that he says in episode 1, this is Neil deGrasse Tyson, that imagination and wonder are key, essential to science, but they're also not enough. So pay attention to that. I thought that was important. And here's the way he puts the history of science, quote, how wandering bands of hunters and gatherers found their way to the stars, one adventure with many heroes. So there you've got this notion of the history of science as a universal human quest. In this case, he puts it in poetic language of aiming for the stars, right? Well, he's an astrophysicist. That's what we would expect. And then think back to Merton and the normative structure of science, norms being rules. In this episode, the very first episode, Neil deGrasse Tyson says there's certain rules for science. So I thought it'd be interesting to just put those up there. And you could compare those to the rules that Merton, remember kudos, those rules that he's got. This is what Neil deGrasse Tyson says is the normative structure of science, right? Test your ideas by experiment and observation, build on the ones that work, reject the ones that don't. Follow observations where they lead and question everything. Remember in kudos, the OS, organized skepticism, question everything. So overlapping but different set of norms, something interesting to look at. Okay, today, like I said, I'm going to try to be brief. Really, this is a selective history of science. I just want us to have an understanding of the development of key interactions between ethics and science. These are things we're going to come across again and again across the semester. So this is really kind of a first pass. I have 3 snapshots, just pictures about science, where we are now in this moment of time. And the point I want you to get across is this great acceleration. In other words, there's an explosion of exponential growth in science very recently in history. And that's where we are now in our moment of time. So the big takeaway from the history of science is that we're in a very formative, maybe even precarious time because of this explosive growth. And then the rest of the lecture, I just have a selective timeline, super selective, right? Ridiculously selective. And these are the points I'm going to go through. So a little bit on natural philosophy, its birth, modern science, Bruno, one of my heroes, I'll say a bit about him, industrial science, and then I've got a focus on 20th century, so post-World War II contract. That's something we're for sure going to come across again, and post-Cold War science when we get into our stuff on science policy later in the semester. And then where are we now? Just some ending speculations about what would you say about science in 2020? You know, what is our moment of scientific history now? People in the future writing history books about science. What is the era or age that we're in now? Okay, so these snapshots of what I'm calling the Great Acceleration, you should just see growth here, right? That's the main message. This is OECD data. This is in your notes. This is research and development funding in constant dollars. You can just see going up and up and up. Another thing I want you to pull off of this slide, here's the US in the lead, European Union, but look at this blue line is China, fast becoming a global dominant player in the R&D world. So growth and also globalization, that's where we are in the history of science. Here, this is a logarithmic scale, a log scale, 3 periods of time. 1650, the first peer-reviewed scientific journal. The next 100 years, well, some growth, but relatively flat. And then look, across the next 200 years, growing more rapidly, but then just in the last 70 years, boom, huge explosion in scientific publications. And, as you might expect, also an explosion in the number of scientists. This is a graph of people with PhDs. And you can see back in if you could take this back to 1950, it'd be about 5,000. This is just in the US. About 5,000 PhDs awarded annually. And now we're up at 55,000. So that's an order of magnitude growth in just 70 years. And you consider the whole history of science. That's a big change, right? So message 1 for you in the history of science, we're in this moment of exponential growth. Okay, here's our selective timeline. This will guide me through the rest of my talk. And again, I just have a few things to say about each of these, not arbitrary, but sort of symbolic moments in time that I've put on this timeline here for you. So the first one, we've already talked about this, right? And I just mentioned it again. Science as a non-narrative, non-mythical, and non-political way of understanding the natural world. When did that arise? Well, in a way, humans have this capacity and have always exercised that capacity. But when did it arise maybe in a more reflective, systematic way? Well, again, my sort of Eurocentric Western version of this is that it arose in the Mediterranean, especially the Greek world, around the 6th century BCE. That's the development of natural philosophy. And again, we've mentioned it's an attempt to explain and describe the world by an appeal to physis and logos, those Greek words, that is, natural things, not supernatural actors, and the logical relationships between those things. Here's the key point I don't think I've emphasized yet, is that this activity, natural philosophy, which would become, through twists and turns, science, was limited to the few who lived on the margins and only talked about this on the margins. It was not exported to the many. And why is that? Well, maybe many reasons. But one of them, most importantly, it was dangerous, right? We'll talk about Bruno in a second. But what happens when you challenge tradition, authority, with your visions derived from this systematic study and observation of the natural world? Often you get strong pushback from the powers that be that want their stories to be in charge about what is reality and what is legitimate authority. So for a long, long time, science or natural philosophy existed only among these elite few on the margins of society. That's the big change with modern science, okay? So I have 4 changes here. We'll get to that one. First, and now we're talking roughly 17th century, right? Number 1, for the ancients, natural philosophy, science was about contemplation. That is changed now. You have a shift to science being about control and manipulation of the natural world. And this is a fundamental ethical point about science. Science is enrolled in these processes to liberate and enrich the human condition, or in the words of Francis Bacon writing around this time, for the relief of man's estate. In other words, the fundamental modern justification for science is to make life better, right? Progress, to control nature so that we have better lives. That's foundational for the ethics of science, and that has a history. And this is when it emerges here, early modern period. The vision of nature changed. For Aristotle and the ancients, nature was composed of these entities, each imbued with their own sort of purpose. According to Newton, right, who's in your Cosmos videos, nature is composed of universal laws, and all different kinds of things obey these laws. And they are mechanical and they can be described mathematically, right? That's a huge shift. Science is institutionalized. Here's the big one I was talking about. We talk about the Royal Society, which is mentioned in the Cosmos videos. The knowledge of the few now doesn't live on the margins. It has a central place in society. It is institutionalized. You have professionals now. That means society not only listens to what scientists are telling them, but adjusts to what scientists are doing. Now you have a scientific civilization when you have science being institutionalized. The other big thing, the telescope, may be symbolic, but also just in its actual reality, changed our understanding of the world and developed this modern scientific cosmology, which is, again, in Cosmos, it does a good job of talking about this. The Earth isn't at the center in some special place. The Earth is just another ball of rocks circling around the sun, which is just another star in our galaxy, which is just another galaxy in the universe, right? So you have not really a natural science, you have a universal science developed in the modern age. Okay, Bruno was at the cusp of this, and he's in the Cosmos videos. One of the things I totally glanced over in this selective timeline is the period of what we call the Middle Ages or the medieval period, where the church and natural philosophy are trying to figure out how and whether to live with one another. And that's the age Bruno is in, right? So that's interesting. He has this vision of God being infinite, and he becomes this evangelist for this infinite cosmos, which is the product of an infinite God. This is a still shot here of people chucking tomatoes at him because he said, reject antiquity, reject tradition, reject authority. What everyone knows is wrong. It's a quote from this little cartoon they put together. Well, he got in trouble with the Inquisition, right? So there we are. There's that shift from the pre-modern to the modern era. It's okay if you want to think those thoughts privately, but you're going to start preaching them, you're in trouble, right? What happened? Well, he was burned at the stake. Note here, Neil deGrasse Tyson is keen to emphasize that Bruno was not a scientist. It was a lucky guess he had, his vision of the cosmos. He didn't have evidence, and he didn't even really have a theory necessarily. He didn't have mathematical laws like Newton had. So he wasn't a scientist, but he kind of was imbued with a scientific ethos, right? Because he was a free thinker. He wanted to think outside of the boxes of dogma and tradition. And that might be the most important ethical lesson from modern science. So not only is it about controlling nature for the relief of the human condition, but it necessitates freedom of thinking and the freedom of expression to share our ideas and to challenge authority, right? Organized skepticism. So this is a picture on the right that I took, actually. I was fortunate enough to visit Rome, and in Campo di Fiori, they have this wonderful statue of Bruno. So I just wanted to share that with you. Fantastic historical figure. Okay, so then real briefly, I think really when you talk about the 1800s and 1900s, you think about the Industrial Revolution, right? Well, that is that early modern vision of controlling nature and institutionalizing science and putting it at the center of society. That's that vision starting to be realized because now we're starting to actually get machines that are cashing out that vision of controlling nature. It took a while, it took several hundred years to put it into practice, right? So science is enrolled in industrial and capitalist societies. You have then what I've been talking about, this emergence of technoscience in a real strong way. And I put this here, you could put it earlier too. Let's not forget that there are many sciences around the world that probably adhere to the same ethos in some way that Neil deGrasse Tyson or Merton are talking about. But the Western science of colonializing powers, especially across the 19th century, right, goes on to dominate and repress other ways of knowing, which may in many ways be scientific ways of knowing, right, about the natural world. And you get this homogenized sort of Western science, for better or worse, right? And we'll come back to this a little bit later in the course. The other thing to note, Darwin, right? So part of the modern cosmology is decentering the Earth, right? We're not the middle of the universe. Well, we could still say humans, though. Humans are the center of creation. Well, Darwin comes along and says, no, actually, we're just one little branch on this bush of life, right? That is another key, I think, ethical dimension of modern science is what does it do? What does it tell us about who we are, right? And where we are in the cosmos. Now, jump ahead post-World War II, and I'm going to go quick on this because this is going to be key to this one and the next one when we talk about science policy later in the course. One, the US dominates the history of science in many ways, not completely dominates, right? But it's like the gorilla in the room, simply because much of the developing world doesn't have much of a scientific infrastructure, and much of Europe has been devastated. You have the instant development of Cold War dynamics that infuse science. Another word for this might be nationalism, takes a very strong hold over the scientific community. You also, though, get the birth of explicit, and this is international, ethical reflection by scientists, especially with the atom bomb. With the atom bomb, you get scientists, not for the first time, but I think maybe for the first time, systematically, collectively, and intensively thinking to themselves about the ethics of what they're doing. And then you also, and we'll get to this later, you have this idea that, and this is really a US-based idea, but again, US was so dominant that it became this sort of default social contract, not that it was written down, but it was kind of in people's head, almost a myth about the way science benefits society. And the basic idea was the fund basic research. This was a term that came out of this era. Scientists pursuing their own interests, guard their autonomy and their freedom, and social problems will be solved. And we'll talk about this later, but it's a little like South Park, the episode of South Park where they have the underpants stealing gnomes. And they ask them, what's their business model? And they say, step one, steal the underwear. Step two, I don't know, right? Step three, profit, right? That's a little bit like this linear model. Step one, do basic research. Step two, I don't know. Step three, society advances. Okay, well, that's me making fun of it a little bit. We'll get back to it. Post-Cold War, though, was a questioning of this linear model. It was people saying, wait a second, is it really as simple as just give scientists money and we'll all live in Shangri-La and utopia? So you get, in other words, the age of accountability. Like, show me that the money we're investing in research actually does good for society. And one of the ways this is cashed out is at the National Science Foundation. Whenever you apply for a grant for that money, you have to talk about the broader impacts of your research on society. So we'll get to this, but that's an important moment in the ethics of science, is no longer just assuming that it will be ethical, it will be good. Now you have to try to prove it and be held to account for that. Part of this is also the development of more, so you talk about scientists after the bomb doing ethical reflection. At first that was just sort of helter-skelter, informal. Well, now it gets formalized in the post-Cold War era in different ways. You get institutions, you get funding mechanisms set up to do what is in some realms called LC research, ethical, legal, and social implications research. So you get this formalized, institutionalized ethical reflection on science with the broader impacts, with LC, and with other things that we'll talk about later in the class. So in some ways, late 20th century, early 21st century is the development of really systematic, institutionalized ethical reflection on science. And part of that is ethics education requirements for scientists and engineers. Where are we now then? Well, these are just speculations. It's stuff I think about. You know, we're still in the post-Cold War era. It's definitely still the accountability age for sure. But there's a lot more going on too, right? We're in the age of science with social media. And that's got all sorts of implications about the way science is communicated and the way it's taken up in society. Science is being globalized. Think about the first chart I showed you with the rise of China, not just China, but the BRICS, those countries, Brazil, Russia, India. This is changing the global structure of science, and it creates intercultural ethical questions that we'll get to. For example, about the treatment of human subjects in research. Right now, I'm sitting here looking at vaccines being approved, for example, in Russia, in a way that may not have happened in the US, and also starting to happen in China in different ways from both of those. So you see the intercultural ethical dimensions of science going on now in a way that I think is historically not unique, but like of heightened importance. Also, we're at the cusp of the transhuman era. Maybe that's really where we are. When people look back at our time, we'll say, oh, this is the moment when science gave birth to artificial intelligence, cyborgs, right? New humanoids, right, Akbar? That's where we are. Or no, this is the moment when science told us about the ecological apocalypse that we're walking into with climate change and with other forms of pollution, or even just with technologically induced collapse. Maybe it's a dirty bomb, atomic warfare. Maybe it's just another pandemic that because we're so tightly interconnected, we can't get out of. In other words, maybe this is science and the Anthropocene, the age of humanity, anthropos, humans, right? Or like I said, the great acceleration. Things are just going so fast and getting bigger and bigger and bigger and bigger. And science is fueling that, right? Okay, those are just speculations. And that's enough for now. That's my very selective history of science with an attempt to focus on some of the ethical dimensions, the big ethics questions about what does it mean to improve the human condition, the importance of freedom of expression, and also about now accountability and how does science actually contribute to the social good. All of those are questions we'll keep digging through the rest of the semester. So I'll leave you with this quote from Akbar in one of his sort of saucier moments, saying that us Earth humans are just beginning at this universal language of science. Something to chew on. Okay, until next time, may the force be with you.